Chapter 1, Reaction Kinetic. 1.1, Rate of Reaction. So in this subtopic, we will learn about differential rate equation, we will learn about rate law, and then we will learn about integrated rate equation. So basically, there are three different equations with different purposes. So what is actually rate? Rate is the change in the concentration of reactant or product over time. So rate is inversely proportional with time. Shorter time taken, the higher rate of reaction. So according to the definition, so if you want to find rate of reaction is change in concentration of any substance over with time. So the unit will be molar per second or mole per decimeter cube per second. Okay, next we will analyze this graph. So A is the reactant. So over time, concentration of A will be decreasing. Okay, because A is a reactant. So in terms of rate of reaction, rate disappearance of A, rate depletion of A, rate deformation of A. So if we transform this word into a mathematical expression, so D concentration of A over dt. D concentration of A means change in concentration of A over change in time. So for reactant, it is decreasing. So that's why we have negative here. While for product is forming, so concentration of product is increasing. So in terms of rate of reaction, so rate appearance of B, rate formation of B. So change in concentration of B over time, so it is positive because B is forming. Next, we will learn about differential rate equation. So this equation will connect between rate disappearance of reactant with rate appearance of product. So A react with B to form C and D. So rate of this reaction, so for reactant will be always negative, and then for product will be positive. And then we will consider stoichiometric coefficient. So if we have 2 mole of A, so 1 over 2. If we have 3 mole here, so 1 over 3. So you need to write down rate. So this is rate of reaction is equal with rate disappearance of reactant equal with rate appearance of product. So this equation we call it as differential rate equation. So it only take aqueous and gaseous state. So if we look at example, so nitrogen react with 3 mole of hydrogen producing 2 mole of ammonia. So the differential rate equation for this reaction is rate of reaction equal with, so for reactant it will be negative and for product it will be positive. So negative change in concentration of nitrogen over time, or this expression also known as rate disappearance of nitrogen equal with 1 over 3 rate disappearance of hydrogen. So rate disappearance of hydrogen is actually this expression. So 1 over 3 rate disappearance of hydrogen equal with 1 over 2 rate formation of ammonia or rate appearance of ammonia. So we look at this exercise. So we need to write down differential rate equation. So this is the reactant. Reactant will be negative, product will be positive, and then we will consider stoichiometric coefficient. If the stoichiometric coefficient is 1, so no need to write down anything. Okay, we will consider gas, and gas. Negative because it is reactant, positive, and then we will consider gas, and gas. And then the last example, we never consider solid. So reactant will be decreasing, and then here you have 2, so that's why it's 1/2, and product will be positive because product is forming. We look at example. Calculation for differential rate equation. Consider the following reaction. So this is the reaction. So given that rate depletion of CH4 methane is 0.25 molar per second. So the question asks you to calculate rate formation of water, H2O. So from this data, we need to transform this one into mathematical expression. So depletion means negative. So change in concentration CH4 over time. So the value is 0.25 molar per second. The question asks you to calculate rate formation of water. Rate formation means positive because it is forming. Change in concentration of water over time. So according to the question, so you only need to connect between CH4 and also water. So according to the equation, negative dCH4 over dt is equal to positive 1/2 because here we have 2. 1/2 d water over dt, and then based on the question, so given this value 0.25, okay, so 0.25 is equal with 1/2, so we only need to calculate rate formation of water, this expression. So we rearrange, so we can calculate rate formation of water is 0.5 molar per second. So the final answer is rate formation of water is 0.5 molar per second. Consider the reaction. So given the equation, but here we don't have any physical state, so we assume all of them is aqueous or all of them is gas. So we consider everything. So determine rate disappearance of HI when the rate formation of iodine is 1.8 times 10 to the power of negative 6 molar per second. So from the data given here, we can transform this one into a mathematical expression. So formation means it is positive, d iodine over dt. So this is the value. So the question asks you to find rate disappearance. So disappearance means this one is reactant. So that's why it is negative. Okay, so we connect between Hi and iodine. So according to the equation, 1/2 rate disappearance of Hi equal to rate formation of iodine. So here we know the value. So we want to find rate disappearance of Hi. So we insert the value and then we rearrange. So 2 times with 1.8. So the answer is 3.6 times 10 to the power of negative 6 molar per second. So rate disappearance of Hi is 3.6 times 10 to the power of negative 6 molar per second. So the answer for the rate is never negative because the word disappearance we understood that one is decreasing. Sama konsep macam saya hutang RM2. Hutang dah faham dah negatif. Kita tak sebut saya hutang negatif 2. So bila kita cari rate disappearance ataupun rate appearance, so jawapan dia sentiasa positif sebab perkataan disappearance dah faham dia berkurang. Perkataan formation atau appearance dah faham dia bertambah. Okay, so jawapan rate disappearance dengan rate appearance is always positive. Okay, so for example number 3, so you can do this one by yourself. So this is the answer. And then for example number 4, you can also do this one by yourself. So for question A, express rate in terms of change in concentration, H2O2 and water with time. So this is actually you want to write down. The question asks you to write down differential rate equation. Okay.